I'm TJ Millis.
I'm Adam Urainer.
And I'm Nasser Rahib.
And I'm Jason Witt.
And we are created a probabilistic language model program in MATLAB. So what we're going to go over is the gathering the data, fleshing out the data, or cleaning it, creating the probabilities, adjusting those probabilities better, and applying those in MATLAB. So what this entails are these things called n-grams, and they come in basic forms. The most basic is the unigram, and that's just the frequency of the word that occurs in the data set. Second is a bigram, and this is just two words, so one after the other, and the probability of that happening. And the next after that is trigrams, and it goes continually after that. So this can go to, like this example is a 5-gram, and it's predicting the next word from a history of the 4 words before it. And this fits really nicely into what we learned in class because it involves conditional probability. Here's just the basic equation of a bigram and the code that mirrors that. So, like I said, the first step is gathering the data. We decided to go with a large data set from novels, the biggest novels that you can find. And after that is cleaning the data, or changing the data into a more acceptable form.
Alright. So one of the issues with going through a large data set for model language is you usually start with a large corpus or a set dictionary of words that you know exist. Depending on the size of your data set, you're probably not going to see everything. The larger you have, the more likely you are to see everything, but when you start looking at bigrams versus monograms, the probability of seeing everything drops drastically. And again with trigrams. So this causes an issue because you can't have a word have 0 probability of appearing because we know it exists, therefore it can be used. So how can we deal with this? Well, the way to deal with it is through probability smoothing, using one of the many methods out there. Some of them are Laplace add-1 smoothing, which basically you go through after you counted all of the words, and you add 1 to every count you have. And then when you go through and divide by your sample size, you actually add in the size of your corpus, which is the number of ones you just added. It turns out that is a very simplistic model and does not work very well. So there are many other methods that they use that redistribute the probability mass using different training techniques or repetition to find a good value that you can add. One that doesn't is the Witten-Bell method, and that's the one we use. And this is based on frequency. So the more often you say one word versus another, will change the probability that you see, or the probability of it appearing. So the basic idea is to go through and find the probability of all the unseen bigrams, for example. And then you would distribute that probability amongst all the unseen bigrams. And then you would go through and start taking that probability mass from the ones you did see. And so this is kind of the idea here. You would go through, calculate the probability of the total unseen, distribute them based on frequency to all the unseen ones, and then you would go back through all the ones you did see and modify the probability to account for the mass you just added. To do this, we actually made it a part of how we parse, or when we parse through the data. So we parsed through, implemented the smoothing algorithm, and we actually went with Python to do this, just for a knowledge base. To do it in MATLAB would require more studying of how they deal with strings and data structures that they have available.
So text data has become an important part of data analysis. so we can transform unstructured text into a meaningful data. For example, an application for MATLAB, we can make a density for the words that become more property to the word that we begin with it. And we can make, as you see here, is the density that the words become much closer to each other by properties. Language models are used in many vertical applications, include a word characters, predict spelling correction and spelling recognition. Given a seed and a language model can generate complete sentence and given entire paragraph based on property given extensive database. For example, a Google search website and a GPS can predict the next words come after it by probability for highest words becoming.
Alright, so with our model that we implemented in MATLAB, we parsed through the engram file created in Python, which is a 70 megabyte file. We put that into cells in MATLAB. We then use MATLAB to create a map object or a hash table, which is essentially a unique key which pairs up the value. And we use chain rule and conditional probability to calculate probabilities from a sample string. Here's just a quick loop in our MATLAB code that loads up the first gram and the following word, and then uses chain rule to compute the probability. Depending on the size of the string, it will continue to do so until it reaches the end. And then on the my left, your right, we have a table, and it just shows here the combination word busiest is a lot higher frequency or more probable in our engram, sample engram. And then we can jump to a MATLAB demonstration of our model. So here is the first script that we made. It's a text in MATLAB. It essentially just creates the string, or the cells we use to create the map or hash table. Okay, so I didn't click around. Anyways, it does that, and then we create our hash tables, or map object in MATLAB, and then with our bigram model. With the given string, right now our sample string is in the, and what is the most likely word to follow. This was a BBC sample set, so we'll just say UK, and that gives the probability that you see there. If we rerun the model and say EU, we get a lower probability, so the word UK is more probable. Will show up in, say, EU. Essentially, that is it for our current model. Alright, so in summary, we have our language model we constructed using engrams. We gathered data from various sample sets and looked at them. We smoothed probabilities for samples that don't show up in our corpus. And then we've talked over applications using language models.